All right, so let's think about how many license plates can we make with 3 letters followed by 3 digits. So this is kind of an extension of the fundamental counting principle here. All right, because basically what I've got is I've got 3 letters, so I want a blank for each letter. Then I've got 3 digits, and so that would be 3 more blanks. So I've got 6 blanks altogether, right? So the first blank is a letter. So how many possibilities are there for letters I could do for that first blank there?
26.
How many letters are there?
26.
26 letters, A through Z?
Mm-hmm.
26 letters? All right. Yeah, there's no restrictions on it, so 26 letters in the alphabet. Now, it doesn't say any restriction, and so usually on license plates, can we repeat a letter? Yeah, you can have an A here and then an A there, right? So if it doesn't say any restriction, there's no restriction. So how many possibilities for the second letter? 26, yeah, you can repeat the 3rd letter, so there's 26 for all 3 letters, right? With me there. All right, now, the 4th blank is our first digit. How many digits are there?
9.
You got 1 through 9, but you also have 0, right? So it's 0 through 9, really. So you got 9 for the 1 through 9, and then you got a 10th one with the 0, right? So there's 10 possibilities. Now, when we were doing the counting numbers, we said the first digit couldn't be a 0. Can this first digit be a 0 here?
Yes.
In a license plate, you're okay with the 0 here, aren't you?
Yes.
So we got 10 possibilities there. And then for the next blank, again, there's no restrictions. You can repeat digits. So you still have 10 here, and then 10 more here, right? Fundamental counting principle says, what do we do with those? Multiply them together. So 26 times 26, and then times 10 times 10 times 10, or 26 to the 3rd times 10 to the 3rd. How are you going to do that? I get 17,576,000. Anybody else get that? Anybody try? Okay? Now, number 2 here, let's put some restrictions on our license plate. All right, so how many license plates can be made using 2 digits? So we'll start with the digits, followed by 4 letters, but let's make it with no repetitions. On either the or on digits or letters. I mean, we could say we could repeat one and not the other, but let's just make it all across the board. No repetitions on digits or letters. All right, so again, 2 digits and 4 letters. We still got 6, but we only have 2 digits. And then we got 4 letters. Okay. All right, so let's do this. All right, so we got the first is a digit. Now, again, on license plate, can the first digit be a 0? Yeah, first digit on a license plate can be 0. That's okay. So we have 10 possibilities there, right? What about the next one, though?
9.
We go down, yeah. Because if we have no repetitions on the digits, we lose one. So whatever we use here, we can't use again here. So there's always going to be 9 possibilities for that next digit. With me there? Now we go to the letters. We start with the first letter, okay? So there's 26 possible letters, no restriction on which letters we can use. What about the next letter, though? No repetition. So we lose one, don't we? 25, yeah, because whatever letter we use here, we can't use here. All right, again, no repetition, so we lose another one, don't we? 24, and then lose another one for that last one. With me there? Everybody believe that? 10, 9. So we multiply those together. So it's 90 times 26 times 25 times 24 times 23. I get 32,292,000. Anybody else get that? What you got? All right, thanks. Okay, so yeah, we can use, we can do some different things, and can be different choices for the blanks there. Any questions on that? Looks all right? Okay. Now, like I said, if you have your calculator, it would be a good thing to have at this point, because I'm going to take a look at a couple of things, a couple of buttons you may have not have used before. Maybe you have, it's been a while. All right, so let's look at this. In a race with 6 contestants, how many ways can the finish occur? A race with 6 contestants, how many ways can the finish occur? And so it's a definite first through 6th place. There's no ties. We're not going to go into that possibility. That would change things up a little bit, but yeah, no ties. All right, so we've got a race with 6 contestants. So we got 1st place through 6th place, all right? So what I want here is a blank for each place. 1st place, 2nd place, 3rd, 4th, 5th, and 6th place. So a blank for each place. First through 6th. All right, it doesn't matter which one we do first. Let's just do 1st place first, okay? Makes sense here, but all right, so if we're doing 1st place first, how many possibilities could there be for 1st place? Well, going in to the start of the race, any of the 6 could win the race, all right? So there's 6 possibilities for the 1st place finish. All right, now, what about 2nd place? Well, it's got to go down, doesn't it? Because why? Whoever finishes first is not going to also finish second. So we lose one here. Whoever finishes first is not going to have another, we're not going to have them in here again. So doesn't it go down to 5? Whoever finishes first can't finish second or any other place. So yeah, we're going to lose one in this case, even though, again, it doesn't say anything about repetitions. You can have repetitions here because that's just the way this was going to work. Kind of like the officer's problem we did. Right, you go down there too. All right, so that's 2nd. What about 3rd? Well, whoever finishes 2nd can't again finish 3rd, so we're going to lose one again, aren't we? And then, what about 4th place? There's only going to be 3 possibilities there because you're going to lose one again, and then you get the drill. 2, 1. Fundamental counting principle says multiply those 6 together, and I believe you're going to get, is that 720?
Yeah.
720. Okay. Now, that's not the only reason I want to talk about this. See if you have your calculator, see if you have a button on your calculator that either is an exclamation point by itself. It might be, you might see like an exclamation point or N exclamation point above a button. Or some of you might have look, if you have an MTH button, press that and see if you have an exclamation point on there. Look on the above, the letters above it. like I said, if you have trouble, just ask me after class or something. You can figure that out. But all right, now here's what I want you to do: punch in 6, and then hit your exclamation point button, or like I said, it could be a X exclamation or N exclamation. What do you get with that? Everybody got it? 6 with the exclamation?
Can't find it on ours, so.
Okay, I can help you after. What, did anybody get it? What did you get? 720? Get 720? Can't find yours? Is that what you got? Yeah. Yeah, mine's above, I don't know if you have the same, mine's above the 3. Right above the 3, yours maybe something different. Do you have an MTH button? That looks like an MTH. Do you have an MTH button? Oh, how about a PRB button? PRB? Could be a PRB.
Yeah.
Got PRB? All right. So hit 6 and then hit that PRB and then the exclamation. See what you get. All right. Yeah, you should get, if you go through those steps, you should get 720. Matching the number here. The reason that matches because what this is what's called a factorial, and it's the factorial is represented with the exclamation button here. This is what's known as 6 factorial. And it's symbolized by the exclamation point. 6 with an exclamation point is 6 factorial. And so what this represents then, it's a quicker way to do 6, 5, 4, 3, 2, 1 product. Right? That's a little quicker than having to type in out all those numbers and multiply them together. All right? So let's try another one. What is 8 factorial? So 8 and then the exclamation. So I got it?
4320.
40,320. Okay? Yeah, so what is that short for? What product? 8 times 7, 6, 5, 4, 3, 2, 1. I call it sometimes the countdown product. Is what this is. Right? Or count up too, I guess, but look at it the other way. But yeah, so it's just a shorthand way of doing a product like that. So you could do it both ways, but be aware that it could be called 8 factorial. All right. I think this was the first time we encountered a factorial, because to be a factorial, it has to go all the way down to 1. We'll look at some that don't go all the way down to 1. Matter of fact, we had one. I should have, if I hadn't erased it, I had one right here that had, it was counting down, but and we did some last time too. It was counting down, but it didn't go all the way down to 1. All right, but we'll talk about that in just a second. So here's another one then. Let's say we've got how many ways can 10 books be arranged on a shelf? How many ways can 10 books be arranged on a shelf? Well, again, if I'm going to arrange 10 books, I've got 10 slots, right? 10 blanks. What do you got here? 7, 8, 9, 10. All right, 10 blanks. So if I start with the first book, how many different books could go here? 10 of them. But what happens to the next?
And it will go keep down.
It keeps going down, doesn't it? Because whatever book you use here, you can't use again, so guess what? What have I got here? This countdown product. So how could I enter that in the calculator? Instead of multiplying them on out, it would be 10 factorial. Yeah. Quick way of doing it would be 10 factorial, so that's going to give me how many? A bunch. 3,628,800 weights. It's a bunch of weights. So you can see why librarians like to place the books. Because yeah, just 10 books, you got this many ways. Just think about a whole library full, how many different ways you could place those. Anyway, all right, question or concern?